Hello students, welcome to Math 1325 Applied Calculus. Lesson 0 covers only the preliminaries, so if you feel comfortable, just skip it and go directly over to Lesson 1 and go from there. In Lesson 0, everything here is a review. Some of it goes all the way back to pre-algebra or even before. So you can skip anything and jumble the order, you can do anything here. So please be comfortable. Let's go to section 1, Algebraic Preliminaries 1. The first topic, set notation. Well, let's breeze through this. Everybody should remember the notations and the expression of sets and elements, the list expression, set builder expression, and elements versus subsets. All good? Feel uncomfortable? Then go back to that optional video. Sets of numbers, NWZQRC, the set of natural numbers, whole numbers, integers, rational numbers, real numbers, and complex numbers. We're going to be using double stroke fonts for these, and please remember all these. Natural numbers, 1, 2, 3, 4, 5, 6, like those, also known as the positive integers. Whole numbers, 0 and 1, 2, 3, 4, 5, 6, and so on. Integers, 0, 1, 2, 3, 4, 5, 6, 7, and so on, but also -1, -2, -3, -4, -5, and so on. All these are discrete. Set of rational numbers, that's not discrete. It consists of fractions of integer over integer, where the denominator is non-zero, of course. The set of all real numbers, this one fills up entire number line so that we can do geometry as well as algebra, both coming together. If we go over to the set of real numbers, we can do graphs, we can do all kind of analysis here. That is the basis for all these. That's the default. If I don't say anything, we begin with a set of real numbers. Complex numbers, we probably will not deal with any of those complex numbers here in this course. Intervals, please remember all these. Semi-inequality is bracket. Strict inequality is parenthesis. And they're all part of the set of real numbers. As I said before, if I skip this, it's still okay, because if I don't say anything as a default, we go back to the set of real numbers. For example, I didn't say anything here, but if I didn't say anything, that means we are beginning with the set of all real numbers as a default. Okay, so much for subsection 1.1 set notation. Let's go to basic algebra. The first thing here is the equality, and equality means equality, literally. The left-hand side and the right-hand side must be equal to each other. Otherwise, it's wrong. That's one aspect of the equality that you have to know. But there's another aspect of equality that is even more important. Let's see, let's come back to this example. 2x plus 1 equals to -3. That's how you read it, isn't it? 2x plus 1 is equal to -3. If you analyze it further, you'll see that 2x plus 1, that phrase is a subject, is equal to, that's the verb, and -3, that's the object of this original sentence. So what do we have? The left-hand side of this equality sign, that phrase is a subject, the right-hand side is the object, and the verb is the equality sign. So that is another aspect of equality, even more important at this level. So if you misuse equality, it's kind of like you're doing English composition and misuse the verbs. Grammatically wrong. If you skip equality, then it's kind of like trying to communicate without verbs. Me, Tarzan. You, Jane. That's about it. You cannot engage in any kind of sophisticated conversation like that. Without the verb, it's impossible. Same thing goes here in mathematics. In mathematical sentences, verbs are the equalities, and in case of inequalities, you have greater than or less than. Those fill in the role of the verbs. And those are really, really important here at this level because after all, a humongous portion of the learning objective of this course is communication, precise mathematical and technical communication. And that begins with simple grammar, the use of the verb. Here's an example. Let's see. Solve this equation. How do you do that? Well, subtract 1 from both sides. You get 2x equal to negative 3 minus 1, which is negative 4, and divide by 2, so we get negative 2. We got the answer, but this is wrong. I hope you can see that. From this red equality sign, left-hand side is negative 2. Left-hand side is negative 4, excuse me. The right-hand side is negative 2. They're not equal to each other. So this is a wrong solution. Correct answer, wrong solution. How much do you get? Half the credit if you're lucky. Depending upon the objective of the problem, your score may go down all the way to 3 out of 10, maybe 2 out of 10. There can be many correct solutions, but here is one attempt. So here, flip this one to the other side, so negative 3 minus 1, so it's equal to negative 4, and then stop. That's the end of the first sentence. And then go over to the next sentence. 2x equal to negative 4, so divide by 2 from both sides. X equal to negative 4 over 2. That's negative 2. You got correct answer, but not only that, you got correct solution. Both are correct mathematical sentences. Okay, now let's go to the next topic, use of parentheses. Well, use of equality corresponds to the use of verbs in your sentence. Use of parentheses correspond to the use of phrase, use of phrases in your mathematical sentences. For example, f of x is equal to x squared minus 1. That's one phrase. G of x is x squared plus 3x minus 2. That's another phrase. And I'm going to substitute f of x as x squared minus 1. Substitute g of x into this phrase, x squared plus 3x minus 2. So whenever you use substitution, put parentheses in there. Whenever you do that. Here are some wrong solutions. F of x minus 3 times g of x. What's wrong here? Well, you didn't close the parentheses. And if you do it right afterwards, okay, I may forgive you, but it may lead to more serious mistakes down the road. The second one is clearly worse. You forgot parentheses altogether, and it's very much likely it'll create further mistakes down the road. And one possible mistake is like this. What's wrong here? Well, what's wrong here will become a bit more clearer if I go over to the next cell and show you the correct solutions. Here's my suggestion. So f of x is the phrase x squared minus 1. All right, I'm substituting that phrase, so use parentheses here. And g of x is this red one, x squared plus 3x minus 2. I'm substituting this phrase, so I use parentheses for that phrase. Make sense? Phrases, using phrases. Oh, by the way, equalities are over here. Left-hand side and right-hand side are equal, and that's equal to the next line, and that's equal to the next line, and that's equal to the next line, like these. So we have all those equalities literally equal to each other, and they're all aligned. There goes one mathematical structure that we just went through. Now let's discuss how to use this parentheses. Use parentheses for these substitutions. Number one, yes. And then now how do I break this? I suggest this. Circle the entire number, including the sign, and then distribute over. Remember, we have two fundamental operations. One is addition, the other is multiplication. How about subtraction? That's just inverse. Just adding the negative number. How about division? That's just multiplying the reciprocal. So here, x squared minus 1, I'm not subtracting 1, I'm adding negative 1. Same thing goes here. The sign is a part of the next number, so I'm multiplying negative 3 times x squared. So we have negative 3x squared. Next, I multiply negative 3 times positive 3x. So we get negative 9x. Finally, negative 3 times negative 2, so it's positive 6. Those are the three terms that I'm adding. They're all additions, you see. Even this 2 is an addition, adding negative 1, adding x squared. They're all additions. This is the best way, in my opinion. Remember to circle the entire number, including the sign. Sign is part of the next number. Once that is done, then you can take the like terms together and then go ahead to the final answer. And circling the entire number, including the sign, will save you from a lot of stupid mistakes. And as for the stupid mistakes, they're really stupid because you don't make those kind of mistakes when there's no stress. So during your homeworks, you don't. And then while you're taking the exam, when it really counts, then you make mistakes. That's stupid. So be smart. Now, the next topic, expansion. So a squared plus b squared is not a squared plus b squared. Square root of a plus b is not square root of a plus square root of b. And this one is a little bit rare, but 1 over a plus b is not 1 over a plus 1 over b. Same goes for subtraction. These things never work. Here's a wrong solution. X squared minus 1 squared, that's x squared minus 1 squared. The second line is wrong. This is how you do it right. You use complete square. Let me talk about correct solution in a moment. I'll show you another error here. Let's see, how about this? Solving this equation. Well, here is the original problem. And do we break up like this? This is wrong. You cannot break up parentheses, or you cannot break up square root like this. It doesn't work. If you want to do it right, you have to square both sides and go from there. Now, how do we get these right? How do you get this right? That's that I think I put it in the next slide here, next section here. Oh, I guess so. All right. So I won't worry too much about that at this moment. I'll just mention this. If all these had been multiplication, then this is correct. If this had been multiplication, then this is right. Same thing here. If this had been multiplication, then this is right. So these work for multiplications, do not work for addition. So these kind of things, they do not work for additions. They do work for multiplications though. Let's see. Final thing here, factorization. I rarely see this kind of mistakes, so oh well, here's a wrong solution. Why do you think this is wrong? You forgot about 6 completely, that's why it's wrong. Correct solution, flip the 6 to the other side and kept the right hand side equal to 0. Now after factorization, because the right hand side is 0, either the first factor is 0 or the second factor is 0 and it works. Does not work if the right hand side is not 0. So make sure to set the right hand side equal to 0 before doing anything else.